If you're a little iffy, I know it was a pretty long episode and there was a lot of stuff introduced. If you're a little iffy on that, just watch this episode and it should help you out. So let's go ahead and start an int main. First thing we do is create this bool isDone variable. And remember, this isDone variable is our flag in our game loop. And what that means is it's going to tell us when we're done playing the game. So we're setting it equal to false, which means that if this statement right here, isDone is equal to false, is going to always be true until we set isDone equal to true. And that's how we tell the game we're done. We say isDone equals true somewhere, and that actually happens right here, because BuyItems will return true or false. If BuyItems returns false, that means everything's fine, we're going to keep playing. But if BuyItems returns true, it means the user entered the number -1, and then we're done playing. So first thing we do is declare the player inventory right here. And remember, it's declared in an array. So this right here, this num items in the square brackets, is telling us how many items are in the array. And remember, num items is a global constant. We could make it just a global that's not constant, but that's really bad programming practice. You should only have global constants, and even then you should try to avoid global constants. But right now we don't know about classes, so we're going to have to make do with this. So we have num items right here, which is 7. It was 6 in the video, but I changed it to 7 and added daggers. You can change this however you want. We can change it back to 6 and remove daggers, but this just makes it really easy to keep track of how big your shop is. If you just have this one variable called num items, then anywhere you want to find out the size of your shop, you just use num items. And if you ever want to change the size, all you do is change this single variable, and it makes everything really, really easy. So here is our shop right here. Here is the player inventory, where each element of player inventory corresponds to an element of the shop. So if we have 0 in this first spot right here, that means we have 0 pairs of boots. Now we have a 1 at the third index. It's actually the 4th element, but it's at the 3rd index, because remember, we start at 0, 1, 2, 3, 4, 5. And we should actually, since we have 7 items, we should set this equal to a 0. There we go. So yeah, remember, arrays are always 0 index. They don't start at element 1, they start at element 0, and they keep going. So what was I talking about? So yeah, here's our player inventory. So this 1 right here means kittens. We have 1 kitten, basically. That's what that means. So if we want to add items to our inventory, we just increment these variables right here. And that happens in BuyItems. So print shop, let's go look at what that does. Print shop just loops through the shop. That is a global variable, remember? So we have this for loop that goes from I equals 0, because remember, they're 0 indexed, and it goes until I is less than num items. And then what we're going to do is print out I plus 1, so that we print 1 through 7 instead of 0 through 6. And then a period, and then the shop item name. And remember, if we want to access an element of an array, we do the square brackets, and then we put a number here. So if we wanted the 4th element, which is poleaxes, we could put a 4. If we wanted kittens, we could put a 3. But we're using the for loop to print all of them, so we're just going to use the variable I right here for our for loop. And then print inventory is pretty much the same thing. It's the same general concept. We have a for loop that loops through and prints out the player inventory, except we do one minor change. We do this if statement right here to make sure the player has at least one of an item. Otherwise, we don't print it out, because there's no reason to say you have 0 kittens. If we had 100 items, then we would be printing way too much stuff to tell us what our inventory was. So then the final part of our game loop here is this BuyItems. And you'll notice we're setting isDone equal to BuyItems. And remember, whenever you do that, that means you're getting the return value from BuyItems and putting it in isDone. And BuyItems is a Boolean function, so it's going to return a Boolean. That's why we have these return true, return false, return false. So first thing it does is asks for the input, and then we are going to store the input in an integer, because we want them to enter a number between 1 and num items, which is a number between 1 and, I believe, 7 in this case. And if they type in a -1, we're going to quit, which means we're going to return true. If we return false, we're going to interpret that as we keep playing. If we return true, up here, this isDone is going to get set to true, and it's going to end our game, because we're going to fall out of this while loop. So if we go back down here, if input is -1, return true, we're done. And then here we do an if statement that checks to make sure that the input is in the bounds. So if they like type a -5 or like a 0, that wouldn't work. However, we're actually doing this wrong. I have a bug here that I didn't catch in the previous episode. This part right here, if input is less than 0, is incorrect. this is going to make it pass if they type in a 0, but we want it to fail if they type in a 0. We want them to type in the number 1 through 7 because we're doing the subtraction right here so that if they type in a 1, we do input minus 1, which gives us 0, the 0th index, right? So if I hit play, I'll show you it should crash. It'll either crash or just maybe something weird will happen. It doesn't always crash. So we're going to enter the number 0, and it didn't crash. We didn't get anything, but it also didn't tell us that we had a bad input. So what's actually happening here when I type a 0 is it's like incrementing some random piece of memory. So this could end really, really badly for us. It could crash the game. In this case, it didn't crash the game. But that's okay. We're going to fix it. We're going to say instead of if input is less than 0, we're going to say if input minus 1 is less than 0, because that'll make sure this statement right here is not less than 0, which is what we want. And then I think this part right here is still correct. Let's see, 7, if they type in a 7, that's fine. So yes, this is correct. And that's it, that's pretty much it. Remember, always have prototypes at the top, and remember your prototype has to match the definition down here. So if we have this bool by items int player inventory here, we need to like make it exactly the same. We need to copy it and paste it up here and make it precisely the same thing. Otherwise, it's not going to work. It's okay if we have like a space here and we don't there at the bottom. But if this is a void and the bottom one is a bool, that's not going to work. Or if this parameter is different or something, that's not going to work. It'll actually, it may not even give you an error. It just won't work at all. And then some people were having issues with reference parameters. They've been trying to pass reference parameters to things. Remember, if you want to do a function that has a reference parameter, say we'll just make a dummy function here, void add 1, and we're going to pass in an integer reference. So we're going to add 1 to the number a. If we want to do a reference, we put an ampersand here. Now we don't put it anywhere else. So I'm going to put add 1 down here at the bottom, like this. We're going to say a++, and that's it. So it should add 1 to a. Now notice I have the ampersand here in front of the a. That makes it a reference parameter. So when we change a, it changes the original a. But when I call, let's say we have a int we, and then we're going to say we equals 0. If we call add 1 with we don't put an ampersand here. We don't put ampersand we. That's bad. That's not what you want to do. You just type we, just like before. Really, really simple. And let's go ahead and see out we, and then this should add 1 each time. So we'll say this is we. This is such a dumb print statement, but I don't care. Alright, so let's do this. Let's prove that that works. And this is a reference parameter. Remember, normally parameters are by value, which means it makes a copy. Oh, I typed in the letter T. Yeah, don't type in letters. We haven't learned how to error check input yet, but it causes stuff like that to happen. All right, so each time I input something, oh, it's not incrementing we because I redeclare we. There's another thing. If I say int we here, and then it adds 1 to we right here, the next time it comes around the while loop, it's going to remake the we variable, and it's going to be a 0 again. So we're going to just keep printing out 1. This is we1, this is we1. If we want to make it so that this only gets initialized once, we type static right here. And now it's only going to get created and set equal to 0 one time. So now when we run it, we should properly get, this is we1, oop, don't want to hit a letter again. This is we2, this is we3. Hopefully you can see it right there above shop inventory. It's working. So that's how you do reference parameters. Remember, parameters are by default by value, meaning it makes a copy. If you want it to be a reference, you have to type in this ampersand in the definition and the declaration. However, remember, arrays are always by reference. They are not by value. Whenever you pass an array, you're always passing the array by reference. It's going to be able to get changed. If you don't want the function to be able to change it, you type const in front. And all that does, it doesn't change the way the program runs at all. All it does is prevent you from changing player inventory. It'll just give you an error if you try to change it. All right, so that has been the review for, I think,